Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
We're here to chat with the data science community. And while this is an IBM discussion, it's going to coexist externally with the Making Data Simple podcast that I host. But the theme of today is, what will data science look like in 2024? I'll just do a quick setup here, and that is, data science is an interesting field. Often I get different definitions depending on who you ask. In the 90s, pretty much, maybe statistics, then became more popular in the mid-2000s, the rise of computational techniques, big data. In 2010, took off with machine learning, predictive analytics, deep learning. Now we're in GenAI. The good news is I've got some great experts here today. I can ask the questions and they can do the answering. Fantastic for me anyway. It's not scripted. I'll promise everybody on the phone that. This is just a fun chat. So the first thing I'm going to do is quick intros, 1 minute each. I'll do myself. I currently run worldwide technical sales at IBM. Spent most of my career in development. Started in data. It's always really my brand. That's why I do the Making Data Simple podcast. I led Watson in AI development for IBM for some time. Also did services, did support, but now I found my way to technical sales. That's me in a nutshell. Darrell, why don't you go next?
Yeah, I'm Darrell Reimer. I'm a distinguished engineer in IBM Research. We're in a team here that is building out the capabilities for Watson X. So we play a role of bridging between research innovation and product delivery as part of the core platform.
Fantastic. Rachel.
I'm an IBM fellow and I'm vice president of client engineering. For those of you who don't know, that is an organization within our pre-sales, our technical pre-sales, that partners with clients on improving out our technology on their use cases rapidly. So say in 4 to 6 weeks, and we have a whole initiative around doing Watson X pilots. My background is that I founded the IBM Garage and built that from a startup within IBM. So I have a lot of focus on agile and really bringing business value to our clients from technology. I will say I'm somewhat new to the AI side. I studied in school, but so like many others in IBM, I'm learning all about Watson X and AI, and it's great. It's so exciting.
Thank you. Suj.
Good morning, everyone. I'm Suj Perepa. I'm an IBM distinguished engineer specializing in AI and machine learning technologies. I'm also the CTO for data and AI for the IBM CIO office. We have an initiative called AI First at the CIO, and we build a pipeline of solutions that are very critical for IBM. And we build those solutions with the latest AI and generative AI technologies. We have a very good set of teams of data scientists, AI engineers, and so on. So I really want to share some really good information with all of you about these roles.
Look at the firepower we have here. Stock price should hit like 200 by the time we end this call. All right, let's jump right in. I want to have some fun with it. First question is very simple, very fundamental, maybe hard to answer. Let's see. Things are moving ultra fast in the AI world. I think it's kind of funny because we've been talking about this. We've been doing this for years at IBM, and give ChatGPT credit. They come out. People can see it firsthand. What is a data scientist today? That's my first question.
I can take it.
All right, Suj goes first. All right, hit me.
So let me start with some numbers. We all have to agree that we live in a data-driven world. And the amount of data we have today in 2023 is 120 zettabytes. And it's going to be 175 zettabytes by 2025. The reason I'm giving you the numbers is there is massive amounts of data out there, and we need people who can process it and gain insights out of that. And a considerable amount of the data belongs to businesses. So the need for these data scientists is ever more important. And what are they doing today? To your question is, I understand they are experts in different types of algorithms and data science techniques, etc. They're also experts in the CRISP-DM methodologies, etc. But their role has actually been evolving and transformed over the last 3 years. So what they're focusing today really are in resolving, solutioning enterprise level applications for the clients. They're operationalizing the AI innovation. They're building models that will process this data efficiently and faster at lower cost, right? And they're doing one more thing that is very important for me, that removing that human error that we see quite a lot when you are processing this data manually, right? In addition to their data science skills and expertise, they're also delving and understanding the NLP and NLG technologies, natural language processing, etc. So they have a combination of these skills.
That's a lot, and I get it. But if you were to net that to one bullet, what would it be?
Data scientists are critical to the business insights.
Thank you for that. Rachel, why don't you go next?
Well, there's data scientists and there's AI engineers, but let's just talk about the skills, right? So I think data scientists, just as Suj was saying, there's sort of this classic data science set of skills that you have as a data scientist around building predictive models, around machine learning, maybe visual inspection. There's a set of those kinds of skills, right? I think then there's also a set of skills which some people put under data scientists and some people do not, and separate out data engineering, which I think is super critical, which is about how do you get all this data that's out there and make it usable for building the models that the data scientists want to do. And then, of course, we have generative AI. And I think generative AI really changes the bars and the set of skills required to do that. It is very different than the classic data scientists. And I think it opens up the ability for people who do not have that full data science background and maybe isn't as strong in math or whatever to become AI engineers in terms of the use of it.
So let me ask a follow-on question, Rachel, based on you went to skills. By the way, I do have a question on AI engineering versus data scientists, which we'll get in a minute.
Right.
So hold for that. But in terms of skills, when can you call yourself a data scientist? I feel like I couldn't call myself a data scientist. I've ran AI engineering.
At least for me, I don't have one answer to that. I think that there's a bunch out there, but Suj and Darrell may have a better answer. Some of the answers I would say are, you have a degree in data science, right? Or a specialty in data science from a college. There's a lot of now data science programs that you get a certificate in. So you've completed a certain kind of work. Are you really a data scientist if you haven't worked in it yet? I don't know, right? Within IBM, we actually have a professional certification as a data scientist. So I think that's one way of doing it. Or you could have, maybe it's that Suj says this person is a great data scientist. I mean, I don't think that there's a single definition of that, but I'm really curious to hear what Suj and Darrell think.
Darrell, the good news is you got to go third. That's, I think, an advantage in this point. So now you should have the best answer of all. So let's hear it, Darrell.
Well, I've always been told to be wary of people who say they're just asking a simple question, right? But if I went to say, try to be a really simple definition of data scientist is, how do you get insights from massive amount of data to solve a business problem? I mean, that's the 100,000-foot view that I have of what data science is. And of course, that's changed over time. Like, the amount of data has changed in the last, say, 20, 30 years. And the types of problems that we can solve with different techniques, the advent of ML, LLMs has changed as well. So that's why I think, the data science role has been evolving incredibly fast, along with the field, in the last number of years. That simple of a definition, though, isn't terribly helpful in saying, hey, are you a data scientist, or what does it take to be a data scientist? The way I look at it is, because it's such a wide and varying space, we have folks here in research who spend their days gathering massive amounts of data, doing some sort of cleaning preparation on it, because they know that they can pull some insight from it. We also have people that are using that data to build some of these, granite models that we're doing. Even within that narrow focused area, that's a wide range of skills. So it's pretty hard to put for me, it's hard to put a single definition on what would make a data scientist there. But I do think that we're starting to see more and more, like Rachel said, of actual certifications or some structures starting to emerge around this. Like the step from ML into LLMs, for example, in my mind was fairly massive. And I think now the whole field is catching up to say, what does it mean to be a data scientist in, 2024 versus what it meant in, 2019 or 2018. So I think we're going to see a lot more of that, of certifications, but we're also going to see it just purely by experience because people are being thrown into these jobs either with a math background or a strong engineering background, or they had been doing statistical data before that and coming out.
All right, I got a question. It's a new question. Now you got to answer it, Darrell, because everybody, and I'll work my way around, but you get the first question this time. How has data science changed in the past year? Like you talk about the movement from ML to LLMs. We've got this generative AI boom now. Has it changed the way we think of the data scientist?
For me, it has. I think, again, this is, you ask 10 people, you might get 10 different opinions on this one. But, we have to say, look, the whole data science world, but it's more than that, right? The tech world, in fact, society has changed pretty radically in the last 2 years with what's been going on. Really, like you said, sparked with the imagination from ChatGPT. And if we relate that back to what it means to us as technologists, as well as going back down, all the way down to what it means for data scientists, yeah, absolutely. We have techniques out there now that didn't exist before. We have more data than we did before. That's an incremental thing. That's been going on forever, right? The amount of data is going up. But now we can do things that we couldn't do before. That the advent of the transformer architecture just fundamentally changed the world. To a lesser extent, ML algorithms did as well, but it wasn't as huge of a step as what's happened now with the transformer architecture. So yeah, more data, but the range of things that we can do with it, those business problems we're exploiting for the data scientists, or the data scientists are trying to exploit, is now really opened up.
Thank you, Darrell. Suj, I'm going to you next. How's the data science world changed in the last year?
The data scientists really used to be highly focused on developing models, right? Predictive models, and then causality models, data wrangling. These used to be their day-to-day work. And they were also very super busy with, supervised, unsupervised, and, reinforcement kind of learning mechanisms, etc. But with generative AI, I think the focus has shifted from actually developing models to actually successfully working with the generative AI large language models. So that's where the prompt engineering skill has surfaced. And it's also about different techniques about the prompt engineering, right? That have become really important in terms of the chain of thought techniques, the RAG modeling techniques, and also React techniques, etc. But at the end of the day, they are working with the large language models, getting really experts with these new techniques of prompt engineering to solve business problems.
I got a question, just a follow-up to all that, and for you, Suj. Look, about 4 or 5 years ago, we always talked about data scientists, and the practice of data science was like 80%, if not more, data wrangling and 20% actual data science. Has that bettered any, or is it still the same?
It has gotten really better. We have really wonderful tools within IBM. Let me mention Watson Studio, a collaborative tool where we can do the data wrangling much, much faster. It would take us anywhere from 80% to 20%. So we can focus on the real modeling techniques, the pipelining of those models. So it has gotten really better. But one more change that has happened. 3-4 years ago, we used to talk to our clients, and we would see an absence of data science teams available with them. But today, almost every client that you talk to have data scientist teams. I think that is also an important thing to point out.
All right. By the way, in the chat, somebody put out a good definition of data scientist. Said data science is a way of explaining phenomena in the world using data as a solution. Pretty simple, pretty straightforward. I like it. All right, Rachel, I got one for you. This is what you referred to earlier. So there's this new term. I don't know if it's a new term, but there's a term that's being used more predominantly, I would say now, in the form of AI engineer. So my question to you is, what's the difference between AI engineering and a data scientist? And if I could, as I'm giving you time to think about your answer here, I'm sure you know the answer, but why the name change? Does it matter? Is it IBM that's really pushing this, or is it an industry change? Are there two separate roles? You tell me.
I think from an industry standpoint, it's definitely out there as a term. I don't think there's any resolution about what it means and what the scope of it is. I think Darrell and I were talking just a little bit before this that even within IBM, there's similarities and differences between it. So from a client engineering standpoint, so I would say the technical sales organization, you and I, we've defined it as more of an umbrella term. And part of that is we've had a set of data scientists in the past, and they also included, some data engineering. And now, because of our big focus on AI and because of the incredible opportunities out there with our clients for generative AI, we've said we're going to expect all of our data scientists to be AI engineers. And we're expanding the pool of people and the pool of skills that we have. So we now have AI engineer as a little bit of an umbrella term where everyone in AI engineering has a set of expertise around generative AI, or certainly around the Watson X platform, right? So those basics. And I would say that means the tuning of the generative AI models, the prompting and governance being across all of it, and an understanding of how you wrangle, at least a basic understanding of how do you wrangle that data. Then within that, there are three subspecialties. One is data science, where we expect people to have all the great expertise on ML and predictive models, because there still is absolutely a place and use cases where that is what you want to be using. And then we have data engineering, which is kind of breaking it out because, again, there's a set of, really important skills there for wrangling that data, and also in our product set in our platform would be .data, WatsonX.data, that they have the deepest expertise on. And then we call it AI solutions. And someone who's specializing in AI solutions would not necessarily have those data science skills, the full data wrangling. They would certainly know the basics of some of that, but they would then have particularly deep skills, not just in prompting and tuning, but also in our AI set of products, where often you may be doing extensions with generative AI, like with Code Assistant, with our Watson X assistants, et cetera.
All right, let me see if I can say that back to you. What I heard you say, AI engineer, tuning, prompting, governance above or with a foundation of data wrangling. And if there's a specialization, there's three specializations therein, which is data science, which is like ML expertise. There's data engineering, which is wrangling data. And there's AI solution, which is around prompting and really being well-versed in the set of products or the platform of AI. Let me pause there. Did I get it somewhat right?
Yeah, I think that's good. I also think it will evolve. I think that what it means now and what it means a year from now, I think it will evolve, both because the technology is moving so fast, the industry is moving so fast. Darrell can talk about how there's a little bit of a different definition in research, and I anticipate that we'll bring that together. But you got it right for where it is today in technical sales.
So perfect. You give me the transition right to Darrell. So Darrell, I put you on the hot seat. Is Rachel just flat out wrong? I love it when Rachel's wrong.
Yeah, I've known Rachel a long time. I don't think I would go with flat out wrong. No,
I didn't think you would.
We were talking. Rachel and I were talking about this a little bit before the call, and I think research is always a little bit different because we're filling a bit of a different role. Obviously, different than what is in client engineering. That said, the way I think of data science and AI engineering is we have a huge range that goes all the way from at one end of the spectrum, I've got data. At the other end of the spectrum, I've got an AI-based solution solving a business need. And together, within those two brackets, we have data scientists that are working closer to that data end, and we have AI engineers that are working closer to that solution end. Where they overlap and how much knowledge goes on both sides can vary a lot depending on the role, the solution, or what we're going after. In my mind, one of the key differences is that the data scientists are really focused on how do I wrangle the data? How do I get the insights out of it? And obviously, with one of the shifts being from a somewhat structured data world several years ago to being a largely unstructured data world now, and basically, let's just use the entire internet to train our models, which is what some of our friends are doing. We have the data scientists on that end. On the AI engineer, I really look at how do they take the piece parts that are coming out of there and assemble them into solutions, and starting to address a lot of the things that frankly have been ignored in the last year, like accuracy, security, scalability of these solutions that are coming out. So really leaning heavily on the engineering side of that term to really pull in the engineering aspects as we try to get out of being the Wild West in AI into really an engineered solution focus.
Do you feel, so I'm a little bit confused. I mean, it's just a confusing world with the evolution of everything. But so I'm a little bit confused. Let me ask you this. Based on what I heard, is there really becoming two camps? I mean, I hate to say that, but is it like the data scientist that is all around data, wrangling? You're right, it's all unstructured. Now we're using the entire internet of things, if you will. I mean, that in and of itself is a full-time job. And then there's another camp of AI engineering after you have the data. Then on top of that, you're doing the prompting, the tuning, the governance, and you work in, you coexist. I mean, you're working and you're integrated. Is that unfair, or do you think that's...
I think just like everything else that we've had, we're going to have a combination of specialists and generalists, right? I mean, we've seen that in other fields in technology, right? So I think that we're always going to have some super deep data scientists that are really get into the data, pull out the insights, and that's probably going to be the scope of their work. Likewise, I think we're going to have a large number of folks that are really on the engineering end that maybe aren't very deep on the data science side, but they can actually build out. They know what it means to secure and scale these solutions. I do think that, even what we've seen in the last year is that even the folks that we are calling AI engineers now are learning more and more on the data science side. And likewise, the data science folks are seeing more and more on the engineering side as the field matures. So I think what I'm saying is it's both, right? We're going to have specialists. We always have specialists in certain domains, but we're going to have a lot more breadth of knowledge across the board.
I mean, I guess the way I kind of look at it, I see those disciplines as equal and very, very important disciplines. By example, on the data scientist side, like we just talked about, the amount of data, it's never going to go down, and it's just the aperture continues to grow. There's two things that worry me about AI in the future, and I've said this on my podcast many times, and I still haven't shied away. It's not Terminator, that's not the worry, but the worry is fake news and cost. And cost is just a business problem, trying to make these available for everybody, particularly when you're dealing with foundational models. But the fake news around data is a real issue, real problem. There are different companies taking different approaches. We're taking the trust approach, which I applaud. There are other companies that I think are betting on, hey, look, if I use copyrighted data, we'll see how it turns out. Maybe I have to pay a fine. That's not our model. But that worries me. But it talks to the importance of the data scientist to get that right, while the AI engineer is working to drive prompting, tuning around these models. Am I thinking right there, or do you think differently? Anybody want to add something to that?
I just want to kind of reinforce what Darrell said, which is, and you're, I think, starting to touch on, there's an engineering discipline around this. And I think, yes, there's a lot of work to do on the data, and there's very different philosophies and approaches being taken. And I think we have to see what happens with the regulations and, frankly, the court cases like the New York Times to see how that goes. And as you said, we've taken an approach of really going after trusted data. I think that's one side of it. I think the engineering side is where we definitely will be evolving this year to exactly what Darrell said, the security, the scalability. But one thing I will comment on is the cost is, I think, going to become a more significant issue. For one thing is the true cost of developing these models and running them are not being really fully reflected in what's costing the consumers today. So I think it will get more expensive. There's also another very significant cost, which is the impact of the compute of these models from an environmental standpoint, and I think that we'll see that also become a more prominent issue, especially as companies have commitments to get to net zero, carbon neutral. That's going to be in conflict with a heavy use of these AI models. Using smaller models may help with that, efficiencies in the underlying compute, which is certainly something we're working on, et cetera. So I think it's just going to be so dynamic this year. But to what Darrell said, which is combining more skills on the engineering side, and I would also say on understanding the real costs and sort of the business side of it is going to be really important this year.
Let me ask a follow-on question on that, because I think that's really important. Go to you next, Suj. Rachel, in client engineering, are you seeing that cost play out? Like, in other words, as we do proof of experience, use cases, activities, we hand this back to the client. Is cost a huge factor for taking that next step and rolling it out to the business? Or you say, no, not really?
I think we're still learning. I don't have a definitive answer to that. I would say in some cases it is. We had one particular situation which was very cost sensitive. And in fact, there was a classification step that we additionally did with an LLM, but we found it could be done with a predictive model, was a little less accurate, but the accuracy was still so much better than the humans were doing, and the cost was lower, that became a factor, and they went with the more predictive model. In other cases, you're bringing such a huge benefit in some of these cases, like the amount of savings is so significant that the cost of the actual cost of running the LLM is a smaller portion of it. I think other concern that comes into play is really what is the risk, because that's a different kind of cost, right? And so I think that we have a point of view on that. We have governance in terms of addressing it. I think more stronger points of view and more practices coming out around that. But when I talk to clients, I talk to them about, what is the business value you're going to get from it? What is the total cost, which is also your people and everything? And what are the risks and how do you mitigate those risks? I think it's an incomplete conversation if you don't talk about and look at all three of them.
But you almost need to talk about it up front so you get the right sponsorship to make sure that this doesn't end in a, I don't know what I want to say. You don't hit inhibitors where you can't roll this thing out ultimately because of the cost.
I will say too that I think that the risk is not well understood in a lot of enterprises. One use case that we did was a regulatory assistant. And on the surface, you might say like, oh, wow, regulatory, that sounds so risky. But in fact, what was being done was model usage that didn't have a lot of room for hallucination. And every step was being reviewed by people, at least until it got to a point where it was proven, like the classification. So there's not that much risk. I mean, when you have people looking at the responses, that significantly lowers the risk.
Makes sense. Suj, you had something to add here.
Absolutely. So, Al, the question that you asked about fake news is a very important one, and I want to spend a couple of minutes on addressing that issue. So, the fake news and poke in the puffer jacket are misleading as well as very not acceptable. So, there is a reason why we should address that, right? And within the US, we all should be aware of the AI Bill of Rights that tells us how to responsibly and in a trustworthy manner apply the AI solutions. It is not to replace the humans, but to augment their intelligence, augment their activities, and so on. We also have EU Act. Within the New York City, we have the NYC law for hiring. And we should all be very cognizant and be aware of all these regulations that are out there. Within IBM, we have AI ethics code, right? And they have created a methodology called ethics by design, I would like everybody to go access that and understand that ethics by design methodology so we can, when we build our solutions internally as well as for our clients, we take those steps into consideration to build trustworthy systems.
Fair enough. Good add. Hey, I've got a question for you, back to you, Darrell. It's something you said earlier. And I mentioned ChatGPT. Look, it inspired interest based on a large language model. But there is a bigger concept, and it's really around the foundational model. And more importantly, as you mentioned, it's the transformer for unlabeled data, which then gives rise to generative AI, which is essentially the ability to create human-like content or new content based on that transformer model. Here's the question. You're in research, all knowing, right? What's next? What's the next big thing like the transformer? And maybe you can go short term, long term. I mean, you can make a prediction. I don't care. What do you think?
I mean, I'm a simple guy, Alice. The way I look at the world is, ML started making some serious advances, right? If we look over the last 5-6 years, predictive models, and we saw kind of a nice incremental gain traction, things that we were able to solve with it. Along came the transformer architecture, and we had a huge step function in terms of what was possible. Since that came out, we've been on, that next kind of gradient, if you will, on that plateau of, hey, we got transformers. What can we do with it? So we're growing it, and it's kind of incremental growth again. I think it's just a matter of time before we see what that next step function is, like the transformer architecture was. It could be, two folks in a garage somewhere that publish the next paper in this space. But things are moving so fast that we pretty much have to count on something coming, whether it's next week or 5 years from now. That's a good question. But there's still a lot of growth to be had, even within the current techniques and approaches. Going to Rachel's point, bringing up risk, which I really like. Things like, how do we address that, right? We have some tools today for trust, but the whole notion of model alignment, how far can we push that to really control what the output of these models are to minimize the risk? Like you said earlier, I'm going to remember this one, that cost is just a business function or just a business concern. Risk, I think, is where we're really going to be paying attention. And I think some of the big advances are going to be coming in that space, how we're going to be minimizing risk, whether it's model-based or architectures around it. There's some really fascinating stuff happening around combinations of models plus additional capabilities, whether it's RAG-like notions, which is like one foot in that door, or even how we're doing model customization. So I think there's a lot of stuff happening. I think there's potentially new architectures coming, of course, right? There's new areas around risk mitigation, which I think is going to be huge. And then I think purely on the performance cost side, look at where we were a year ago at this time. The cost for us internally to run these models from where we were a year ago to now is over an order of magnitude cheaper and faster now than it was then. Like a lot, actually quite a bit over that. And we expect to see a similar gain in the next year. So I think there's three fronts, right? Architecture, risk, and performance.
Nicely done. Nicely done. I wanted to pause for questions, but before I do, Rachel, do you have anything to add, number one? And I guess the next question, given the use cases in what you're seeing in client engineering, are we slanting our dialogue too much on Gen AI? I mean, there are other forms of AI.
I think that's a really good question, right? One thing I think we watch out for is a little bit of a danger that generative AI is the hammer and everything. It can be done. It can do everything, right? But sometimes you need the screwdriver because the hammer doesn't work in the screw. So, there you need more predictive models. You need more classic ML. Like the case I was talking about for the classification, it was really good that they went back to, use a predictive model. So I think that, it's generative AI is not the only thing. I don't know if I'm quite answering your question, but I do think it has enormous possibilities. And to what Darrell said, I think we'll see evolving architectures around it. I'm very interested to see what happens with RAG, or retrieval augmented generation, this year. And does that really change with context windows? Really, there's real benefits to it, et cetera. So I think we'll keep seeing these patterns evolve. I think generative AI is, super exciting. The other thing that I will say is a lot of the times generative AI has been equated with LLM, and certainly that's where most of our business work is. But there are other generative models coming out. A bunch of them are already out there around images and things like that. And we, from an IBM perspective, will have more coming out. We already have our geospatial model with NASA, which is really interesting for how it can help with climate change and farming and things like that. So I think that right now, this equivalence of generative AI to LLM from a business perspective, we'll see that really change in 2024.
Nice. Any other comments, Suj, Rachel, Darrell, before I pause? Suj has got her hand up. Yes, go ahead, Suj.
So I think not leveraging large language models, generative AI, is a non-starter. I think it is a transformational technology that we all need to adopt. But I also suggest that we do that in conjunction with the traditional AI. There is a lot more value, lot less cost when we have traditional AI and generative AI working together. And while we look at future, one more quick point is we have these very useful, very simple word I'm using, useful, but very necessary task of text generation and code generation. There is huge value that we can deliver through those two initiatives for clients and for IBM. I think we should go after those two initiatives and technologies and make the best use of them, and then look forward to how we can improve decision making based off of that before we go after other technologies. But I totally agree that in combination with traditional AI and generative AI, we get huge value.
Thank you, all three of you. I do want to pause and see if there are any questions that our fearless panelists can answer.
Amazing session. Thanks a lot, everyone. How does having such a low barrier to doing data science can change where the field will go in the future? And then the second part is that if there are like any risks.
A quick shot at that, right? I think, to me, one of the promises that we have, so if we look at the approach that we've taken in IBM, we're not a one model to rule them all company, right? We're telling the story that you can use smaller models customized for your environments to achieve similar results at lower cost, right? So if I look at that, we now have put the burden on ourselves to how do we actually find the right models and how do we customize those models for these new environments? And if the answer to doing that is, well, step one is you hire a team of highly skilled data scientists, we're not going to succeed. So to me, this is all about how do we lower the barrier to achieve some of these goals that people who aren't as deep in, say, data science can still participate and achieve good results. I was just using the example of tuning models, right? It should be the case. Today, it's you really still have to be a data scientist to tune a model with successful results, give or take. How do we change that barrier so that we can really democratize it and open it up for people who are maybe even just app developers to do it? So I think, to me, that is going to be the first thing. Then the second side of that is how do we do that without introducing a huge amount of risk, right? So we've simplified it, but have we opened up room for issues?
Darrell, I agree with you. If I was to answer that question, I know I'm not one of the panelists, but I'll jump in. Look, first of all, I think there's going to be multiple tailored models, but being a data guy does come back to the data. And if you want to talk about risks, it comes back to what data sets you're using. This gives the importance of a data scientist. Like, by example, there's a popular data set called C4 used by Google to train their encoder decoder T5 foundational model. It has the copyright signal in it 200 million times. Just one example of a data set that has copyrighted or proprietary information in it. You use the wrong data sets. One, you could get the wrong answer if you don't know what data set you're using, but you also could put yourself into legal issues eventually. Like I said earlier, some people are doing this intentionally, presuming that they can pay their way out or otherwise at the end of the day, and in return they get all these data sets. That's a risky proposition. You need to know what you're getting into.
I have observed that there's a fairly significant distinction between those who work in the deep science work of model development and those who have deep business knowledge and data analysis insight. I also noticed it's rare to have an individual who is very good at both. I think you spoke of it, but do you notice there's more of a lack of a data analyst or a business analyst working on a data science project? And how might we build organizations that recognize this and leverage the skills and passions of each?
Suj, do you think we're going to see an integration of business analysts with that they will learn the generative AI portion of the prompt engineering? So the more basic part of it, prompt engineering, prompt tuning. Is there any reason in the future that we wouldn't see that merge more? Because there's always this goal of sort of the no-code, low-code solutions to the business, which is usually the business analyst. We have this in other areas. We see this in our Watson Orchestrate product. We see it in our Watson Assistant, or Watson X Assistant. So I think maybe that will happen. I don't think that we see it quite yet, but I think we'll see that happen, because then you're, as a business analyst who knows at least the basics of generative AI, you've increased your value to the company.
Yeah, I think that will be great if they can evolve into that role, right? By understanding the nuances of the transformer technologies and looking at the results that we get through the prompt engineering, right? And analyze the data, analyze those results, come up with new techniques to feed it back into the system. I think that would be great. I'm looking to the day where we have an automatic prompt engineering based off of the content that we ingest, but also human intervention, human oversight into these things. That's why I'm really fond of and think it's critical to have the business analysts and data analysts in the team.
So I'll do a shout out to some of our consulting leaders, because we have an extensive internal tool consulting's using for doing their own business. And one of the things it does is actually suggest some prompts for their RAG solution. It ingests some content, and then it suggests some prompts. I don't know that I don't think it's as sophisticated as what you're talking about, but kudos to them for already being there on some of that.
Yeah.
I'd like to end this as I do my podcast with a very simple question, real quick. What do you guys do for fun? Rachel, what do you do for fun?
I travel, I hike, I hang out with friends.
Fantastic. Darrell, what do you do for fun?
A lot of hiking and driving kids around.
Driving kids around. Everybody's hiking. Okay. And Suj, you're?
I love to travel and read books, but as the spring is coming, gardening is my passion.
Well, with the three of you, speaking of books, and I often end with this as well, is there a data science book or an AI engineering book that you would recommend most?
I'm writing one.
Well, it's not done yet, so I guess we can't recommend that. We could do the preview. Any thoughts?
I haven't been doing the book route so much. I've been doing much more videos, articles, things like that. I think we have a bunch of our YouTube channel with our Lightboard sessions. Suj, I was watching you over the weekend doing one of them, right? And I find those are really, really valuable for understanding a lot of the concepts and things like that.
I think the panelists did a good job today, having no prep whatsoever. So fantastic. Cool. Thanks everybody for listening.
Thank you.